So hello everybody, this is team number 22. We have made this wonderful game known as Eat the Treat, wherein the objective of this game is to collect all the unwanted objects in the basket below. In the top left corner you can see that there are 3 lives, so you get 3 chances to collect all the wanted objects, and in the top right corner your current score is displayed. So as you can see, I'm collecting only the wanted objects. Now the wanted objects are strawberry, red apple, green apple, plum and cherry. So you have to only collect this wanted objects. So I'm collecting wanted objects here. If you collect any unwanted objects, your life will be decreased by 1. And after at the end of after when you collect 3 unwanted objects, the game will be over. So when your score is above 20, if you would have noticed that the speed of the falling objects has been increased. Again, when your score is above 40, the speed of the falling objects again increases. So this is our game. I will just show you the help screen again. So when you press the help screen, you will get all the instructions that are necessary to play this game, and at the end of the game, you will get options to again play again or exit the game. So thank you everyone. So this is our game. And
Hello friends, we are team 22 and we are 6 in members, so we implemented 6 design patterns for our game. Yeah, change. The patterns are state pattern, observer pattern, decorated pattern, factory pattern, again an observer pattern for some other reason, and command pattern. I'll start with a state pattern. Basically a game starts with a not started state, and when you click on play it will go to the has started state, then to has life state, and if you continue to remain in has life state until you are collecting a correct objects. But when you start collecting unwanted objects you tend to lose life, and then you enter into no life state and to game over state. When you exit you again go to the not started state, but when you click again it will go to the has started state. Here is a class diagram for the same. So I'll just show you some classes for it. Currently you are in not started state. Here are some here is the not, like you can see, is no not started state, no life state, and so on. When I click on play, I'm into the has life state, and then when I collect object I continue to be in has life state. When I collect wrong object I'll lose life and change to no life state, and hence I'm in game over state. And when I click on play again I go to the has life state again. As simple as that. The next pattern that we have implemented for our project is a command pattern. The command pattern is basically for swapping between the screens. So as you have seen over here in the game, we are now in the game screen, but when I lose life I go to when I lose life
hello. So now let me demonstrate to you how we have implemented the 2 observer patterns in our game. So this is our start screen. Let me just play the game. Yeah. Uh, so as you can see, the basket is grabbing the various objects that are falling down. We have implemented various scores for the different fruits that falls down. Like for cherry and strawberry, the score of 5 is added, and for every other fruit a score of 1 is added. Now when the total score reaches above 20, the speed of the falling object increases, like you may have noticed it now. And it is implemented the same way if the score reaches above 40. And also the second observer pattern that we have implemented is that for every unwanted object like the ladybug or the rocks or bombs, if the basket eats them, the life is decreased by 1. So I will just show you how it. So here, as you can see, that the life has been decreased by 1. So this is how we have implemented the 2 observer patterns. So the another pattern that we have implemented is the command pattern. Now we have implemented this pattern for traversal between various screens. Now the various screens that are in our game are the start screen, the game stop screen, the exit screen, the basket game screen, and the help screen. So now the screen that you seeing now uh, is the start screen. After we press the play button, we go into the basket game screen, and when the scores are displayed, it is in the game stop screen. When you press the exit button, it is in the exit screen, and when you press the help button, it is in the help screen. So for your reference, I will just show you the class diagram for the command pattern. In this pattern, the invoker invokes the call on buttons, and the commands are registered on screen slots required, and then the command sets the receiver. Thus, in this game, we can travel from main screen to the game screen, help screen, or exit screen using this command pattern. So another pattern that we've implemented is the factory pattern. So as you can see, we have divided the various objects that are falling from above into two classes, that is unwanted objects and the wanted objects. So in unwanted objects we have bombs, rock, fly, and ladybug. In the wanted objects we have strawberry, red apple, green apple, plum, and cherry. So the requirement of our game is for these objects to be developed randomly at the runtime. So for implementation of this requirement, we have used the factory pattern. For your reference, I will now show you the class diagram for this pattern. So this is the class diagram for the factory pattern, wherein the object class has been extended by all the objects that are required to be created randomly. So there is an interface called as I create objects, and another factory object called as object factory. So in object factory there is a make object function, and in the object class we have drop objects function and act method. So this is how we have implemented the factory pattern for dropping the objects randomly at the runtime. So another pattern that we have implemented is the decorator pattern. This has been implemented to calculate scores depending upon the type of the wanted objects received by the basket. So different types of fruits object calculate different scores value using a decorator pattern. For example, any fruit received increases the score value by 1, especially the strawberry fruit. If received by the basket, then the score is increased by the value of 5, and for cherry it is increased by the value of 3. So this is how our decorator pattern is implemented. For your reference, I will just show you the class diagram for the decorator pattern. So this is the class diagram for the decorator pattern. The iScore decorator is an interface which is being implemented by two classes, the decorator class and the concrete component. And the decorator class is again being extended by strawberry decorator and cherry decorator. If you remember, we told you that if strawberry is eaten by the basket, its value is increased by 5, and if cherry is eaten by the basket, its value is increased by 3. So so this is how we have implemented the decorator pattern.